Let's take a couple minutes to talk about the key terms for circuits, so that when they come up and we use them, you'll be able to know what we're talking about. So first of all, we're going to talk about a voltage difference. So if there's a voltage difference between two positions, so say at this position right here, or between this position and this position, there's a 5-volt difference, then that means that the charges would move, and in particular, they're going to move to lower potential. So if moving from here to here would increase, from left to right would increase the voltage, then charges are going to tend to want to move from right to left. They're going to want to move in whatever direction causes voltage to drop. That's just the natural flow. And this is similar to objects on Earth naturally moving downward, because in that case they're moving to lower gravitational potential. So if we've got a positive charge here and I put another positive charge here, one way to talk about it is this positive charge moves away because it's moving in the direction that lowers the voltage, that moves to a lower voltage farther away. So the other way to think about it, that'll come up specifically here, is if I have a battery, then the battery will have an increase in voltage when you go from one side to the other. So in other words, all the electrons at this end of the battery want to move around to the other end of the battery to where the voltage is lower. So the battery has a high voltage end and a low voltage end, and the electrons want to move, if you connect up a wire, from one to the other. This introduces the idea of current because the flow of charge is known as electric current. So if things are flowing, if charges are moving, because, electric current. If charges are moving because of that voltage difference, that's what creates a current. And the current is represented with the capital letter I, and it's measured in coulombs per second, or also known as amps, which we represent with the capital letter A. So it's coulombs per second, or amps, which we represent with the capital A. So when charge is moving from one place to another, we call that current. So unfortunately, there are two kinds of current, and this is the result of discovering and defining this idea of current before protons and electrons were known about. So the first one that we have is something called conventional current. And this is the direction that we imagine positive charges moving. So if there were positive charges moving through a circuit, they would move in the direction of conventional current. And unless otherwise told or given, we always use conventional current. So when we talk about current, if we just say current, we are almost always referring to conventional current. So pretending like positive charges are moving through the wire. And then we also have something called actual or physical current. And this is the direction that electrons move. And it will be the opposite direction of conventional current. And you can think about this as in, if I have a bunch of electrons moving to the right, then that's going to make whatever's on the right more negative. If I have a bunch of electrons moving from left to right, it's going to make whatever's on the left more positive over time. It's going to make whatever's on the right more negative over time. We can just as easily imagine, now this isn't actually happening, but we can imagine positive charges moving from right to left, and that will have the same result of making the thing on the right more negative and the thing on the left more positive. So when scientists originally were looking at electricity, they had these things that they called positive and negative, And then they said, oh, well, current is when charge moves from one place to another, and we'll just say it's when the positive charge moves from one place to another. Later on, it was discovered that, oh, the thing that's actually moving is the negative piece. So technically the stuff, the physical stuff that moves, is negative charge. But we can easily imagine, and all the math works just the same if we think about it as positive charge. So I know it's going to get a little weird and a little confusing, but it's just something that we accept and work with because of kind of the historical development here, unfortunately. And then the last term that we want to talk about here is resistance. And resistance measures how hard it is for charge to move. It's represented with the variable, or sorry, not the variable R. Represented with the variable R, and it has the unit of ohms, which use an uppercase omega as the symbol. So resistance is the measure of how hard it is for charge to move. So if something's not very conductive, it's going to have a high resistance. If you've got a piece of metal, that's going to have a low resistance. And again, we represent that with the variable R, and the units are ohms, which we represent with the symbol omega. So let me know if you have any questions, but otherwise we'll wrap up here.